Hi friends, welcome to the channel. Today I will walk you through a full data science project from collecting the data and downloading it from Kaggle into pushing it and publishing it into your GitHub to showcase it to your future employer or just to grow your portfolio. So what are we going to do on this project? First, we're going to download a static dataset from Kaggle. Second, we're going to upload it on Google Colab. Third, we're going to talk about the libraries that we're going to use. Four, we're going to do data exploration and see what we can get from the data set. And five, we're going to analyze the whole data, asking a bunch of questions and see what we could make sense out of the data. Six, we're going to do visualization, some nice visuals, we're going to interpret them, and then we're going just to conclude the project. Here, I try to not include machine learning. I don't want to just use a simple code for machine learning and tell you that that's all that is to it, because there is so much complexity. There is the whole pipelines for deployment, and there are some additional things that we need to do in order to deploy a fully functional machine learning model. So I decided to keep these into the data science sphere. No need to add much complexities. This is very beginner friendly. The only prerequisite is some Python programming skills, since the whole tutorial will be written in Python. Let's dive into it. First, we're going to Kaggle.com. We go to the dataset section and we can choose any of the datasets available on Kaggle. So you can find a bunch of different categories. You can find anything you're interested in. You can find datasets on Netflix. You can find datasets on football, whatever pleases you really. Like, there are so many things that you could look for. But for our tutorial here, you can even find a lot of competitions, the code available, discussions. Kaggle is like the #1 dataset provider on the net. So there are a few others, but this one is one of the most famous ones. So the one that we're going to work with is this one. It's quite cool. It's video game sales and ratings. It will remind you of some childhood games, which is quite cool. So to have a look at the data itself, you can look directly in here. You can see it's a CSV file, not a big file. There are 17 columns. You can read them in here: name, platform, year of release, genre. So you can filter the quality of the data directly on Kaggle. If you see that the data is missing a lot of columns or rows or values, you can just choose another one. Or you can decide to work with one that lacks information and you'll have to do a lot of cleaning. So that's also valuable. And here we can see the structure. It looks like it's clean, it's nice. It has a bunch of information about sales, about the publisher, the genre, and also the platform, etc. So we can easily just download it from here. And it will be downloaded here, as we see, archive4.zip. If we open it, we'll find it in here, and here it is. It says video games 2.csv. It says 2 because I already downloaded it here, as you can see. So I already got this one. Okay, so next step, we'll go to Google Colab. Let me make this bigger. We're going to here upload our data set. Okay, I think I have it already. No, it's not in here. So we're going to upload it. Going to our downloads, and we're going to put the first one that I have in here. They're the same, basically. Okay. It will be now added in a few seconds, and then we can use directly the data set. As we can see, it has been added in here. We can use it directly. So here we choose Google Colab. It's on the web. It's quite fast. It gives you a good RAM and CPU to use directly in here. It has Python 3 built in and a bunch of libraries already installed. So you don't need to install all the libraries. Some people use Jupyter notebooks. Some others can use any IDE, like Visual Studio. I do as well. But for the purpose of this video, we can use Google Colab. You just go to Google, you type Google Colab, and it should be this one, colab.google. You open it, and you can start a project from scratch. New notebook, and here you are. But since we don't want to spend hours typing everything from scratch, we're just going to use the information that we already have here. So the goals, we're going to upload the datasets, what we just did, import the libraries, we're going to explore the data, clean it, analyze it, and then visualize it. And there will be a bonus of machine learning at the end, and a predictive system, and the recommender, sorry. And that's just a bonus, and you'll find all the code available on GitHub. So I will link everything in the description below. So you're going to find all the code and also the data if you want to download it from here, all on GitHub. I'll also show you at the end how you can upload yourself, your project into GitHub, so you start building your portfolio. Okay, so first we're going to import libraries. So the first one here is pandas as PD. So basically this pandas is a library that helps us manipulate data frames. Data frames are basically tables in Python. NumPy is for using arrays and numerical, and Matplotlib, Seaborn, and Plotly, the three of them are for visualizations. I like the most Plotly. It gives very high quality visuals, which I like, but sometimes it's also nice to use the other libraries as well. And here we have sklearn, which is a library that does a bunch of things in the data science world, but here we're going to use it to switch or convert, data, which is strings or anything else, into numerical values. And usually this is done if you want to do machine learning, because the machine only understands numerical value. But this is, as I said, it's just a bonus, and the bonus you'll find it at the end, but this is not really the purpose of the video. Okay, so part one, we're going to explore the data. So now we're going to import our data frame. We'll do df equal pd.read csv, because we have a CSV file, and we call it. And since we have it already uploaded in here, we don't need to put the path because it's already in here in Google Colab. But if we didn't have it, we'll need to put the path of our file, whatever it is on our computer, so that the program recognizes what it is. And df.head will show us the 5 first rows of the data frame. Let's do this. Oh, it says PD is not defined, of course, because we didn't read first the libraries. Now that we read them, you will recognize the pandas library by using PD, as we see in here. Okay, here we are. We see now the first 5 rows. If you want to see more, you can put whatever number you want directly in there, and you can see them. You can explore your data, see what are the features in here, and from here you can start already thinking what type of analysis you want to do. So we'll keep this one shorter. If you want to check the last 5 rows, you can just switch head with tail, and it will give you the last 5 rows for whatever reason, if you want to check the last ones. Okay, so here we go. We have 17 different features or columns. We have a bunch of rows, and we want to see how many rows and columns we have. We just do df.shape, and it will give us here, as mentioned here, rows, column. So 16,928 rows and 17 columns, which is a medium data set, not too big, not too small. So we can do a bunch of things with it. Here, if we do df.info, it will give us first all the columns available, and here it will give us the count of each feature, how many of the inputs are inside each and every cell. So here, as we can see, 16,928 is the whole sample, but some others here only have 8,000, 8,000, 7,000, so they're missing values. Okay, and here we see dtype, which gives us the type of the feature. Integer is a numerical, object could be a string or text, float is also numerical, and so on. So here we can already have a good idea of what's happening in our data set. It's important to know if a feature is missing values, because in our analysis we need to get clear on these things, because you can't compare things that don't have values. So you will either eliminate the rows that don't have the values, or you will replace them with mean values or with the average or any other technique that is relevant for your project. Okay, here df.isNull.sum will give us the sum of all the null values. Here, as we're doing is null, and we do the sum, and here we can see even better how many missing values we have in each feature. When I say feature, I mean column. Okay, so platform is a feature, year of release is a feature, and so on. Here we can ask a simple question just to start. How many games have both critic and user scores available? So for example, here we see user score have 6,769 missing values, and critic score has more than 8,000. So if we want to check here, we can just do games with scores. That's just the name of a variable we did. We just choose only these two features, and here .drop NA means that we want to drop those values. Okay, so what we do here, we just drop the values, as easy as that, and we have only 8,222 rows left. So we had at the beginning 16,928 rows, and when we remove the null values from these two columns, we only have 8,222 rows left. Here we do df.describe. This one does a descriptive statistics of the data set, and as you can see, it only includes numerical values. Here we can see we have 11 features out of 17, as we've seen in here. So all these ones that are objects are not shown in the df.describe. Here is quite nice as well if you want to see the mean value, the standard deviation, the minimum, the maximum, the values in between. You can also see here the count. In the count, you can see how many values out of the full data sets are available. Okay, so here what we can do is we can ask some relevant questions that we can do analysis for. So the way I proceed usually is that I open my data set, I explore it, I see if there are any missing values. I can fill them with mean values or average values, or if you don't have any option, and if you do, for example, the average and it will bias your data, it's better just to drop it. As we did in here, we kept it simple. We don't want to bias the data by putting the average. And now we're going to put some questions that we're going to answer. And that's the whole point of doing the analysis. So here we have, what publishers have the higher global sales? What platforms have the higher global sales? What genre have the higher global sales? And what features correlates with higher user score? So here we're going to start by the first one. Here I've put this one. So for those of you who are wondering if you want to open your whole data frame without any collapses, I mean, usually if here I come in here and I put df, I remove the head, it should show us the whole data set, yeah? But as you can see here, after 4, it does close it or collapse it, obviously, so that it doesn't open 17,000 rows in a row. So it just limits the CPU usage, which is understandable. But if you want to see all of it to have a better look, we just do display.max rows and we do none, meaning it will not stop it. And if we do it, it will show the whole data. It can take a few seconds, obviously, to open the whole data set. You can do the same with columns. If you have like 60 columns or something, it will be also collapsed, and you can use max columns in here and it will work. So it's taking a little bit of time. We can wait, and here you are. So we have the whole data set in here. So for us to not bug the system, we're just going to put it back as a comment. We use hashtag for comments so that we can come back and focus on our work. Okay, let's answer the first question here. What publishers have the higher global sales? So here I compacted the program into just one cell. You can split it, depends on how you prefer your workflow. Since we have 4 questions, I wanted to structure them like this. You have a whole code with the visualization at the end, and it will be the same for each question. I just prefer to do it like this, but it's your choice. You can do this part in one cell, for example, then you jump on this part in one cell, and then you do the visualization in another cell. That's proper to you. So here first we're going to we want to answer the question, what publishers have the higher global sales? We're going to check if there are any missing values in publisher and global sales columns. So we'll create this variable missing values equals to df. We're going to only keep these 2 features. We're going to check if there are any missing values and do the sum of it, okay? And then here we're going just to print if there are any missing values. You will say, okay, there are 50 missing values, or 20 or 0, whatever. That's just the first check. Then here we just want to exclude those missing values. So what we do in here, we just do a variable called video games cleaned df, and we go to drop na, which is drop null values, from the subset of publisher. Okay, so here we check them, and here we just drop them. Okay, because we can't just replace publishers just by the average or the mean, we'd rather just remove them to not bias our output. Here we're going to aggregate the global sales by publisher. So what we do in here, we're just going to group the publisher and the global sales, and then we're going to sort the values in a descending order. That's why here we have ascending equal false. We'll have a descending order. And here we're going to display the top 10 publishers by global sales. So basically the 10 publishers that have the highest global sales. We're going to see here, top publishers, the variable. It will have this publisher sales, and we'll show only the 10 first row. That's why we have dot head. And here we're just going to print the top 10 publishers by global sales, and we're going to put the output. In terms of visualization, here we're going to use matplotlib. That's why we're using plt.figure. So if we go back in our libraries, we have matplotlib as plt. So every time we want to call this library, we just call it by calling it plt dot and the rest of the code. So plt.figure, we put the figure size. We usually start with putting a size 12 to 6 inches. Here we put the top publishers, which is this variable that we want to plot, as a bar, okay? And we'll give it a title. We'll give the Y label a title as well, the X label a title as well, and here it's just a rotation information, which is 45 degrees. And we do plt.show. We're going to enter. As we can see, let's start from the beginning. We see the missing values. We see there are 55 missing values for the publisher. They're going to be dropped, as we've seen in here, drop NA, and then we're going to do the sum of the aggregation between publisher and global sale and sort them in descending values. That's why we see in here Nintendo, Electronic Arts, it's on a descending order, and our visual will also be on a descending order. And here we see what are the top 10 video game publishers by the highest global sales here in millions of dollars. Okay, this answers our question number 1. So I kept the structure of the code the same. So if you already understood this part, you will see that to answer the other questions, we're going to follow the same logic. Okay. Second question, what platforms have the higher global sales? So here we had the publishers, okay, publishers. And now we're going to check on the platforms. So basically the same analysis. We're going to check if there's any null values. And since I've already checked and I found out there is no missing values, that's why I didn't drop anything, because there is nothing to drop. Here we're going to aggregate global sales by platform, same as we did previously. Then sort the values in a descending form. We're going to show only the first 10. You can do top 5, top 3, top 20, depends on what type of analysis you're doing. If you're working on a project, what your employer asking from you or the client, you can adapt. Some people will want the top 3, and you can simply go for a top 3. And visualization, we did the same. So the same size of figure, we have a bar plot. The title is the top platforms by global sales. Here we have global sales for Y label, X label is platform, and we're going to show, and here we're just putting the output results. Let us do it. As you can see, we have 0 missing values for platform or global sales. If we had some missing values, we could have dropped them. And here we have the platform in a descending order. We can see the PlayStation 2 has the highest global sales, and the 3DS is the 10th one, for example. So for my analysis, as you might have noticed here, I took the global sales. So the global sales are the sum of all the sales around the world. This is North America, this is Europe, Japan, and other sales. I just chose global sales. If you're more interested, for example, on the sales just in Japan, you can do the same process, but you change the feature global sales into Japan sales or Europe sales. Okay, so here we continue. We go to the next one in here, PlayStation 2. Okay, to the next one. Here, if you want to just check the top platforms, that we already see it in here, so we don't really need it. Now we're going to answer what genre have the higher global sales. So here, if we come back to the dataset, we can see the genre, sports, the platform, racing, role-playing. We might be interested to see which ones perform the best or lead to the highest global sales. So we're going to do the same. Sorry, here we are. We're going to check if there are any null values. We're going to drop any null values if there are any. Here we're going to again aggregate both features, and we're going to sort them in a descending order. And we're going to print the first 10 rows, or the top 10. And here we're going to use Plotly, and you're going to see that Plotly is a bit more interesting than Matplotlib. It has a nice visual, and you can also hover on it. So let's have a look here. We put figure equals to px.bar. So px, if we go back here, Plotly express as px. That's why we use px. We come back, and here we put all our information and characteristics between parentheses. Okay, so we have top genres, because we're using this variable that regroups the top 10 genres in terms of global sales. We have x is top genres dot index, and y is top genres dot values. Basically, index are the genres that we have, different categories, and dot values are how many appearances, basically. Or here we're talking about sales. This will be the sales number. And the title, we have top genres by global sales, and the labels for X we'll put genre, and for Y it's global sales in million. Easy, and you're going to see that the visual is quite nice. As you can see here, you have action is first, and you see when you hover on it, it gives you the information within the bar. You can adjust the color, you can make gradient colors, and you can really adjust as you please. If you wanted to do ascending, you just come in here and you do ascending equals to true, and it should be ascending. These are just details. Depending on what you want, you can just adjust the output. Here Last question, and the fourth question, we have what features correlate with high user score. So for example, we are interested to see what does affect the user score. Usually when users give a score from 0 to 10, what do they look at more to give their score? Is it maybe the genre, or is it the publisher because it's Nintendo, or is it because of I don't know, the brand Super Mario or whatever? We just want to see if there is any correlation between the user score and any other feature out there. And in order for us to do it, we'll need to convert the features that have an object or text or string into numerical values. Otherwise, we can't do correlation analysis. So we'll see all of this right now. We come in here and we're going to use df user score because that's what we want to analyze, and we will do pd dot to numeric, okay, because here we want to convert user score into numerical values. Okay, so we can use them. Here we're going to initialize the label encoder. The label encoder basically is what is going to allow us to encode or convert any type of data into numerical values. And here we have it from here, sklearn preprocessing, which encode features to make them numerical for ML or statistical analysis, in our case right now. Okay, so here we go. In here we're just going to create a simple for loop that will go each column through all the columns in our data frame. Yeah, we're going to check if the column is object type, and then if it's object type, then we just want to transform it into a numerical value. So that's the process here. We just check df column dot dtype if it is equal to object. Okay, so we've seen before in here that we have some features that are objects. Okay, and then we're going to convert the object type columns into category type. Okay, and then we're going to apply a level encoding on categorical columns. All of this so that we have all of the features numerical, so that we can do the correlation in here, the correlation matrix, and then we're going to visualize it. So how we're going to visualize it? We're going to include we're going to use PLT, which is matplotlib, and SNS, which is the third visualization library, which is called Seaborn, as you can see, SNS, and we're going to use a nice matrix, correlation matrix. Might take a bit of time. Okay, as we can see, we have all this correlation matrix in here, a bunch of things that we can see. So here, just from a quick look, I can see that, for example, user score doesn't have any relation with the sales in North America or EU or GP or sales in general, because usually people, when they buy a game, they don't really care about the how many games were sold. Maybe they're more interested in who developed the game or the ratings or the genre, but not really on how many sales were made. So what we can do is we can go in here and select only some specific columns. So I came in here and I removed all the EU sales, GP sales, NA sales, and I kept just these ones that are potentially more interesting. Okay, so we're going to create a new data frame. It will keep it still df, but it will have only the selected columns, the ones that I chose in here. Okay, and the process, the rest is literally the same as before. So we can have something more concise. As we can see, this is already a bit more interesting. And here we can see, for example, the two highest correlations that we can see. User score is with the critic score. So usually there is a big correlation between what the critics say and what the user says. So here we have 0.58, knowing that the correlation goes from -1 it means it's negatively correlated. It means if one goes one way, the other one goes the complete opposite way. And +1 is the maximum, meaning that they are 100% correlated, meaning they move the same direction all the time. Here we have 0.58, and for rating, we have it's correlated highly to developers. So we can see for the user score, all of these correlations in here are quite low, except for the critic score. So we can come and then just add a text and say, we found that user score only correlates with critic score with 0.58, while there is no much correlation with other features. For example, obviously you can go more in depth and you can try and analyze it even further, try to analyze other features as well, other correlations, and so on. Here we are in part 2. We're going to do some more analysis. So first one, we'll see trends over time, going to examine how video game sales have changed over the years and identify periods of significant growth or decline. The second one will be to check the regional preferences. We're just going to compare the popularity of genres or platforms across different regions, like North America, Europe, Japan, and the rest of the world. And third one, we'll check the correlation between critic and user scores and explore how closely user opinions align with professional critics. So we've already seen it in here. We've seen that there is a correlation between user score and critic score, but we can dive a bit deeper into it and visualize it properly, just the two of them. So let's start here with the first one. The first one is we're going to analyze the trends over time, examine how video game sales have changed over the years, and identify periods of significant growth. So here we're going to only keep a subset, which is year of release, and we're going to drop null values from it. Then we're going to convert year of release into integer. We're going to do it here as type int. We've seen before that year of release is a float, okay? So we're going to change it into an integer. As easy as that, you just put as type int. You can change to any type as well. Aggregate global sales by year, as we've done before. We're going to group by both features, year of sales and global sales.sum. We're going to sum them, and then we're going just to plot. Here we're going to have a different type of plot, which is a line, and the rest is basically the same. I'm just going to print it, and here we are. We have a nice visual. As we can see in here, there is a massive growth starting from 95 into approximately 2008, and there is a big decline again after 2008. There was the recession in 2008, which might explain a bit the decline, but there might be further reasons to it. I recommend highly with every visual to put a description, especially when you're trying to you do an analysis to get some specific output. And here, for example, the whole point of these analyses is to see the growth or decline of the sales of video games over the years. So here we can put just a few points that are relevant. Here we can see that say that the data set has data from the 80 into 2020, that it started peaking from mid-90s and peaked in around 2008. The highest global sales occurred in 2008, and then it declined consistently after 2008. So here you can go and do deeper analysis and deeper research on Google and check a few articles and try to add things that are relevant. See why really it declined after 2008, because the data here sometimes won't say everything. It's just a starting point for you to do even more research in other places, and you can even come and add them into your analysis. Okay, here we just mentioned that there is not much of sample data after 2016, and that's why here we have like nothing, because we just the sample of data set doesn't include 2016 and further ahead. And we just do a quick summary in here. So every time you create a report, just add a description, add as much details as you can, even in the visual itself, like a good title, the X and Y labels as well, because usually you report to your clients or your employer, and some of them are not really technical, or some of them don't really have time to just make conclusions themselves. You don't just give them a bunch of visuals and you're like, here you have the analysis. No, you need to give them beautiful visuals and also descriptions and put some key ideas. So for them, they just check, they see quickly the points that are okay, worth diving deeper, worth investing in, and so on. Okay. Second one here, we want to check the regional preferences. We're going to compare the popularity of genres or platforms across different regions. So here we're going to group by genre, and we're only going to keep the sales. We're going to remove the global sales and keep the North America sales, the Europe sales, Japan, and the other sales, which regroups the rest of the world. It could be Africa, some Central, South America, Asia, and so on. And we're going to plot it. We're going to use again a bar plot of size 14:8, and we have the title, X label, Y label, and we have our rotation 45, which is going to show. Okay, here it is. Here it is. Let me just diminish from it. It's a beautiful visual here. The blue one is North America, the orange one is Europe, green Japan, and other sales. We can clearly see that the blue ones are the highest in all of them, maybe except in here, yeah, role playing, which we have Japan have a little bit more, but usually North America, which is USA and Canada, have more sales. And you have just to be careful with this type of data to check what was the purpose of the data collection, because sometimes the data could be biased because the person was more interested in just North America and Europe and Japan, and they neglected the rest of the world, and that's why you have really low sales for the rest of the world. For example, if you were asked to do the same analysis for a country like Bulgaria or whatever country you choose, this dataset might not be really relevant, even though Bulgaria could be classified as Europe, yeah, but still it's just one country out of all these countries in Europe, so it doesn't give you much of an indication. You'll either need to collect your own data and then do the analysis, or you need to look for specific data sets that are relevant for your own specific research. Okay, but here we can see the second one is mostly Europe and then Japan, except there are a few exceptions, like here we have role-playing Japan is higher than everyone else. Okay, and again we're going to do a nice and small description. We're going to put here North America has the highest sales in most genres. The Europe, similar to North America, EU also shows a strong preference for action and shooter games. So basically we give a description, and this is what the whole purpose of the analysis is all about, is to get these conclusions. That's the whole point of cleaning the data, analyzing the data, exploring it, visualizing it, is for in the end getting these answers. Usually if you work for a client or your employer, usually they know what they want you to look for, so it's quite straightforward. You just doing the process, so in the end you can give them that answer, and the answer could be as simple as a few bullet points, a few visuals, a few bullet points, and a nice conclusion. Here you are. Number 3 here, we want to see the correlation between critic and user scores, which we did earlier, but now we're just going to regroup just these two features and explore how closely user opinions align with professional critics. So we're going to drop null values from the subset that only contains these two features, okay? And here we're going to convert user score to numerical values if it's not already. So that's just a step that you can add. Sometimes you can find that a feature is an object, but still it has numerical values. Okay, so in that case, you just need to convert it into numerical values. That's just an additional step just to make sure that it's numerical value. Okay, because you can only calculate correlation for numerical values. You can't correlate a feature that has numbers and another feature that has text. The text should be converted into numerical values so that we can check for correlations. Okay, and then we're going to drop any rows that have none values, which is null values. Basically, we drop NA from the subset user score in place equals to true, meaning directly in the data set. It will drop the null values directly in the data frame itself. Okay, and now we're going to calculate the correlation. We use dot core to calculate the correlation, and then we're going to plot. We use a combination of matplotlib and seaborn. I usually use seaborn all the time when I do correlation. Okay, so here we're going to do the correlation. We're going to take the correlation from the variable here, correlation. Dot to f, we just mean that it's two decimals after the comma. Okay, and we're going to do it. And here we have the correlation between critic score and user score is 0.58. That's what we've seen earlier in here. Okay, user score and critic score. But now we have a deeper understanding, and we can see clearly each and every data point in the data set that we have. Okay, so we can see here that these sum of all these points give us a correlation of 0.58. So if it was a correlation of 1, it might have been like a straight line, and every point that is a critic score will be exactly the same as user score. For example, if critic score gives 8 out of 10, user score will give also 8 out of 10. If it's 6 out of 10, user score will be also 6 out of 10, which is not realistic because usually they should be different. And here we can see that the correlation is nearly 60% correlation, which is, if you think about it, makes sense. Usually you don't find a critic score of 9 out of 10 and user score 1 out of 10. Rarely. Usually they're quite close. Not necessarily the same, but usually they're quite close. So yeah, here you are. The last part here is machine learning. As I said, it's just a bonus, and you can find it on my GitHub directly, which I'm going to share in the description. And you can go and have a look and try it by yourself and see if it's something interesting. But I will cover machine learning in other videos. Just let me know if you're interested in it or what type of applications you want me to cover, and we can do it. So if you go on my GitHub, github.com/anesriad, ANESRIAD, you're going to find here on my profile is the first one in here. If you click on it, you should get the whole code, the README that details what we've done. You'll find also these sales prediction and recommendation systems that we didn't see today, but you'll find all the rest. Okay, and here you find the data set and the code that we went through today if you want to go and play with it and try yourself. But what I recommend is for you to go to your GitHub, create your own GitHub. It's free, it's easy to sign up. You go to your profile, create a profile. If you don't already have one, you go to repositories and you're going to create a new repository. Just click on new, call it I've already done it, but it's okay, video games, let's say data science or whatever, or portfolio, or you can call it as you want. You can put it public so you can showcase it. Add a readme file. Okay, readme file basically is where you put all the details about the projects, and there you explain all the steps you went through, because someone just coming and seeing a bunch of code, it's usually not easy to understand. So this is mine, so you can take inspiration from it, see how to structure it, keep it easy, just say what you've done, what was the goal of your project, and some of the techniques you use, And when any potential employer or recruiter or whoever is going to check, they'll be like, okay, the person knows what it does, and they know how to structure their things, and it looks legit, not just copy pasting code and putting it into your own GitHub and that's it. So you just come in here. We're going to come in our Google Colab, download.ipynb, which is a Python file. Okay, here we have it. So it's video games 2 because I already downloaded it twice before. So you're going to come in here. Obviously, we're going here to improve the readme.md. You're just going to modify it as I did in here. Okay. Then you will come into add file, upload files, come in here, going to put your file and the CSV file if you want to, but it's not necessary. You can put in the readme.md file, you can put just a link to the Kaggle dataset. And if someone wants to replicate your work, they will go download and follow your approach. Okay, so we can come back. As we can see, it's all done. We're going to commit changes. Okay, and here we have our readme.md, our CSV file. If you click on this, you're going to find your beautiful code all in here, and anyone can access it. Okay, just a few recommendations here. Try and add as many comments or hashtags as possible. It helps people who come after you to understand what you're doing. So obviously here I added a lot more than usual so that you can understand. I want you to understand everything that we've used. Okay, and it's also helpful if you collaborate with someone to put comments for each other, and when you name variables, make them clear. Okay, so that the person who can work with you or after you doesn't have to go through the hassle of understanding each and every variable. Okay, so here you are, you have the whole code. There's the machine learning part you can have a look at, and if you're interested in anything, just let me know what type of topic, what data set, share with me on the comments, and I will make sure to cover it for you. Now that you've created the whole project and understood what each component is used for, you can now reproduce the same thinking and the same approach in any other data set that you find out there. You go on Kaggle, you download any data you're interested in, and you follow the same structure as we did. Remember, always when you finish any project, save it and push it into GitHub so that you build more and more your portfolio so that you can showcase it for your future employer, or just put it on your LinkedIn profile or whatever social media you're using. It gives you more credibility, and that's the best way you can showcase your experience as a data scientist to anyone out there. Thank you for watching, and if you have any suggestion on any project related to data science that you want me to cover, or if you have any questions that I didn't answer on the video, just put them in the comment section and I'll do my best to respond to all of them. And if you have any topic you're interested in, just let me know in the comments and I'll make sure to cover it in one of my next videos. If you're interested on how you can become the greatest data scientist you could be in 2024, make sure to watch this video here.